find me on Twitter at srobtweets, or you can tweet us at Google Cloud. So here's what we're going to cover today. First, I'm going to get started by talking about some image detection apps you probably use on a daily basis that you may have seen in the wild. Talk a little bit about how those work. Then I'll dive right into the Cloud Vision API, and I'll walk through what it is, how you can make a request with it, what the request returns, and then we'll do some live coding in Swift, and we're going to use Firebase in the demo. It'll be super awesome. So to get started, what is some image detection in the wild? So you probably all use Google image search. Here's a lovely image search of Minneapolis. I'm sure you all use this on a daily basis. So this is using a lot of machine learning algorithms under the hood. It's giving me a lot of suggestions. For example, it's bundling photos of attractions in case I'm looking for that. Maybe I want photos of maps of Minneapolis, skyline, etc. It categorizes all these photos in a really smart way. Another example, how many of you use Google Photos? Lots of fans. So Google Photos does a great job of categorizing all your pictures. These are just some screenshots from my Google Photos. Categorize like all my selfies, all different places I've been. We can even do search. I don't know if this is coming through here, but like I search for cats, pictures of my cats come up, pictures of cat statues. I can search for running. It shows pictures of like races I've been to, sunset. It's really good at categorizing all sorts of things. But how do these work under the hood? What's going on there? So neural networks are a big part of this. And essentially what neural networks are is they're using computers to simulate the way that our brains distinguish and recognize different patterns. So like when you were very young, you learned to distinguish a picture of a cat from a dog, for example, which you might think of as a pretty trivial task. But this is actually pretty difficult to achieve when you're doing this with computers. And this is essentially what neural networks try to do. So as you feed these neural networks more and more data, their accuracy improves with training as time goes on. And Google's been working with neural networks for a long time, and recently open sourced something called TensorFlow. A tensor is a multidimensional array. So TensorFlow is essentially a data flow framework for tensors. It was open sourced in November of last year. You can go check it out on GitHub, github.com/tensorflow or tensorflow.org. So it's an open source machine learning library for researchers and developers to build and train their own models. Currently it's available with Python and C++ APIs. And it's being used in many areas across Google. I definitely recommend checking it out. So some of the Google products you may be familiar with, these are actually powered by TensorFlow. So speech recognition, whenever you use OK Google, your speech recognition app, that's using TensorFlow under the hood. Same with Google Photos, as you saw before, it can do like pretty crazy categorization of all sorts of images. You can say like, show me pictures of my dog, brings up all the pictures of dogs. And then Gmail also uses this to categorize your emails. And then I don't know how many of you use the new Inbox app. That's using TensorFlow for smart replies. So I don't know if you noticed, like recently there's a feature where it'll suggest replies to your emails based on the content in them. And then that's using some machine learning algorithms like that under the hood. But what if you're not a machine learning expert? What if you don't really want to have to deal with understanding like all those models that go behind these applications? Well, that is where the Cloud Vision API comes in. So essentially what the Cloud Vision API does is it packages all of these machine learning algorithms that we've been working on at Google for a really long time into a really nice, easy to use REST API that lets you do pretty complex image detection. So right now there's 6 different types of detection it can do. The first is label detection. So if you pass it an image, it can return, it can tell you different tags of what's in that image. The one on the bottom right is an example of that. So this image passed the Vision API, returned rapid, canoe, slalom, kayak. So it can detect objects in the image. It's pretty impressive at this. I'll show you some examples a little bit later on. The next thing you can do is landmark detection. So for example, like a picture of the Eiffel Tower. If you pass it to the Vision API, it'll return Eiffel Tower. It can give you the latitude, longitude coordinates of that. And it's able to identify some pretty obscure landmarks, which I've been pretty impressed with. Logo detection is another example. So you can pass it a logo, and it'll identify the company's logo. Face detection is probably my favorite. So it's able to find faces in an image, and what it returns is the bounding box coordinates of each face in the image, and then it can also detect emotions. So it can detect joy, anger, surprise, sorrow, and it returns a string based on the likelihood of those emotions in the image. And then it can also identify different facial features, so like left eye, right eye, nose, chin, etc. So that one is pretty cool. And then text detection uses OCR, so it works in a variety of languages, I think like over 20. If you show it an image of text, it can return text that's in that image. And it can also tell you which language it is and the locale code for that language. And then finally, it can do safe search detection, so it can detect inappropriate content. Really useful if you're building an app where you want to screen for malicious or inappropriate content. You can do that very well. Yeah, so just diving a little more in depth, as I mentioned before, it can find multiple faces in an image, returns the points for each of these facial features, as you can see here. So location of eyes, nose, and mouth. It can detect a bunch of different emotions, and it can also find common objects and landmarks and their location in the image, which is pretty cool. And then, as I mentioned, it can detect explicit content. So let's take a look at how we would make an API request with the Vision API. So it's pretty simple. All you do is you send it some JSON with the base64 encoded image string as the content, and then you just tell it the type of feature detection you want to run. So here we're doing label and face detection. You could do all 6 if you wanted to, or just 1. And then you tell it the number of labels or faces you want it to return, the max number. And that's pretty much it. You just send that to the API, and then it returns a bunch of data on the image, depending on what you've asked for. So now I kind of want to go through some of the images that just some examples of images that I've sent to it with each different type of feature. So let's see it in action. So this is one of my favorites. So I went to New Orleans a couple weeks ago and took a picture of a beignet. And like, this is a super close-up picture of a beignet. Doesn't even look like it exactly. But I passed it to the Vision API, and it returned beignet as one of the labels that it found. And it also returns a score of like how confident it is that this is what it identified. So that one was like 0.92, so 92%. It also returned like dessert, profiterole, powdered sugar. So I thought that was pretty cool. That's an example of label detection. Then landmark detection is another one of the features. So I'm a big Harry Potter fan. Any other Harry Potter fans?
Woo! Woo!
Yeah, Harry Potter. So when I found out about landmark detection, I was like, I wonder if it can find Harry Potter World. And it indeed found Harry Potter World. So I passed it this image of Harry Potter World in Orlando, and it returned here the Wizarding World of Harry Potter, along with the latitude, longitude coordinates of that. Then it also shows you, it returns the bounding box of where it found that in the image. So logo detection is pretty straightforward, as I mentioned before. Here's an example of the Google logo, which it identified as Google. And then also returned a bounding box. I didn't show all the XY coordinates here, but just a bounding box of where the logo appears in the image. And then this is an example of face detection. This picture of me and my friend who actually lives in Minneapolis. And it returns, so you can see that it said joy likelihood, very likely, because we're smiling. And I cut out part of the response here, but it just returned a separate object for each face that it found. And then with that, the position of all these different facial features in the image. And then finally, text detection is pretty cool. So I chose a sign that's in Japanese here. It says no parking. I don't speak Japanese, but I had to look it up beforehand to confirm that the response was accurate. So here it was indeed able to identify that this was in Japanese. And then it returned a bounding box of where the text was in the image, and then the actual string of what the text said, which is pretty awesome, especially because the text doesn't take up the whole image, and it's able to find that area where there is text, identify the language, and return each individual character for you. So I'm going to go right into a live demo. First, I'm going to talk about what we're going to build. So we're going to build an iOS app in Swift. Any Swift developers in the crowd? A few? Just one? Cool. Well, then you'll learn something new, hopefully. It's going to run label detection on the image and face detection, actually. And it's going to store the label data in Firebase. How many of you have heard of Firebase before? Looks like most of you. I could do like a quick Firebase overview before I get started. I actually might do that, just to make sure everyone is on the same page. So here's just kind of a diagram of what it does so you can understand it a little better. So you'll be able to choose an image, it'll send it to the Vision API, which is what this is denoting right here. And then the Vision API will return some data about what's in the image. And we're gonna just store that data in Firebase. So it's a pretty simple example, but it's kind of meant to show you like all the different applications and use cases you could build with the Vision API and using Firebase to store data. So let's dive right into it. So I want to start by just doing a quick Firebase overview for those of you that don't know what Firebase is. So Firebase is essentially a platform for building applications. It makes it really easy to build apps. You don't have to worry about writing any backend code or spinning up servers. Firebase takes care of all that for you. It's got 3 client libraries, so it's got a JavaScript client for the web, and then iOS and Android clients for mobile. And so right here is a Firebase database that I'm using called DevFestMN. It's a NoSQL JSON data store, and every piece of data in Firebase has its own URL. So you can see here it says devfest-mn.firebase.io.com. So that's the URL of this Firebase data. So first I'm just going to do a little bit of JavaScript here. I'm going to pull up the console. Make that a little bigger. And so the first thing I need to do to write data to this Firebase is get a reference to my data. So right now I'm using the JavaScript SDK. In a moment I'll be using our iOS SDK with the Swift app that we're going to build. So the first thing I'm going to do is I'm going to say var ref equals new Firebase, and I'm going to pass it this URL. And now I have a reference to my Firebase. There's 2 ways to write data to Firebase in our JavaScript SDK. The first is set. So with set, it'll update the location with whatever you pass it. You can pass it a string, a number, an object, or a Boolean. It'll update that location. So here I can say ref.set hello, MN. And we can see that that changed there. If I write something else, if I say hello everyone, it changed again and it overwrote what was there before. So if instead, so set is useful in certain situations, but let's say you've got a situation where there's a lot of people adding data to the same node at the same time, and you don't want to have any write conflicts. So in that case, we've got a method called push, which will create a unique ID every time a new piece of data is added. So in this case, I'll say ref.push, hi again, and we can see that it created this unique timestamp-based ID for me. And if I call it again with the same exact string, it didn't overwrite what was there before, which is pretty cool. And you can nest your data also. So I could say, here, let me clear this out. So if I say ref.child messages.push, and then I'm going to push an object where the text is just going to be hello. And we can see it created this messages node with this separate object. And I can click on this, and we see that the URL changes. And it also works as a REST API, so I can append .json to that URL, and I get a REST response back. So that is the basics of writing data to Firebase. And to read data back, I'm actually going to go back to the root. To read data back from Firebase, you attach an asynchronous callback to your Firebase reference. So I actually need to declare the reference because I refreshed the page. So I'll do that quickly. So make sure everybody can see it. So I'm going to create an asynchronous callback that's going to be triggered anytime the value of this Firebase location changes. So I'm going to say ref.onValue. And this is going to return a snapshot. So it's essentially just a snapshot of that data at that point in time. Since Firebase is a real-time data stream, it's always changing. So whenever this function is called, it's going to return the value of what's there right at that moment. So here I'll just console.log snapshot.val. I think I did that right. Yes. Okay. So here you can see it logs the value of all the data in the Firebase. But the cool thing is, if I go here and change it, characters, I changed it, and because the value changed, that callback was triggered again, and I didn't have to write any extra code to make that happen. It's always listening unless I cancel it. So that's the basics of reading and writing data to Firebase. So back to the demo we were going to build. I'm actually going to clear this out because we'll be writing some different data in there momentarily. I'm going to open up Xcode. I've got my request URL here, and I'm going to post that URL. And so first thing I'll show you is just how easy it is to create a request. So I'm going to call it JSON request, and it's going to be of type string dictionary. And this is just going to equal, so first we've got our request. Within that, we've got another object, and remember here we've got our image, and within our image is just our base64 encoded image string, and that's going to be image data. So I'm passing that into the function. I've got a function up here that base64 encoded image, and then calls this create vision request function. So I'm just passing it that base64 encoded image string there, and then the next thing is the features. So for this one, I think we want to do label and face detection. So here I just need to tell it the type of detection I want to do is label detection. And the max results I'm going to return is 10. And I'm going to do the same exact thing. I'm just going to copy this. Same exact thing for face detection. And we'll also return 10 for that. If anyone has any questions, by the way, feel free to interrupt and let me know. I'll do my best to answer them. So we've got our request object ready to go. We're setting the body of our request here. And then the first thing I want to do, so I'm running the request on a background thread. The first thing I want to do is just print the response I get to the console. So here I'm using a pod called Swifty.json. Pods is basically iOS dependency manager, CocoaPods. So Swifty.json makes it easy to parse JSON in Swift. So I'm using that pod here to parse my response. I'm checking for an error. If there's an error, I'll print the error message. Otherwise, I want to print the responses to the console. Got my last response in there. And I'm going to go ahead and build this. And now I've got the simulator running. Got a couple pre-selected images here. First one I'm going to load is just this lovely latte picture. And it worked. So let's see what it returned. So it's pretty fast, and it returned some cool data on my picture of this latte, flat white, which I think is a type of coffee drink. Latte, drink, coffee, meal, breakfast. So it's returning all this metadata from this coffee picture, which is pretty cool. I will do one more before I display stuff in the UI. I've got this picture of like a bunch of stock photo of just people smiling. And hopefully it'll return some face data we can look at. So here it returned an object for, make this a little bit bigger. Return an object for each person that it found in the picture. So it says, are they wearing a hat? Very unlikely. Then it returns landmarks for each of the features in their face that it found. So that's pretty cool. So it's a bunch of data. I won't go through it all. But basically, it returned a different object for each face. And since they were all smiling, joy likelihood is very likely for most of the people in the picture. So we can do a lot with that data. So the next thing we want to do is I'm just going to copy in some basic code to, instead of printing it, we're just going to display the label and face data in the UI. So I've just got a snippet here. Paste that in. I'll go through that real quick. So this is what I just pasted in right here. So first we get the label annotations, and then we're just creating an array, which is a string of all the labels, and we're basically appending that to the UI. So we're just creating a comma-separated string. If there's no labels, we post no labels found to the UI, and then we get the face annotations. And here I'm just calculating an average percentage. I've assigned numbers to each of the likelihoods for the emotions. So I'm just calculating like the overall emotion of the people found in the image. And then I'm just displaying that. So nothing too fancy going on in the UI. Let's rebuild. And again, I'll choose this smiling people picture. And you can see that it's a little hard to read up there. But basically, it showed social group, photography, person, people. It's detected 9 people in the image, 90% joy average in the picture, 12% surprise, and it didn't find much anger or sorrow, which is a good sign. application, a good use case for the Vision API is if you've got an application with tons and tons of images, it might be nice to like store all the metadata for those images so that you can do like a bunch of types of analytics on them. So just to show you how you potentially do that, we're going to write some code to store the labels in Firebase. So I've imported Firebase, and then I won't scroll through it, but I have my Firebase URL set up at the top of the view controller here. And so I can write the label data to Firebase in just one line of code. So all I need to do is say self.ref, which is my Firebase reference, and I'm going to use child by appending path. In JavaScript, that was just called child, so when I said like .child message, in Swift we say child by appending path. So I want to store all the labels under a separate labels node, and then I'm going to say child by appending path again. I'm going to store their label description, which is just the string value of the label description. And then I'm going to set that to true. So I'm not going to use push here. I'm just going to say set the label to true when we find a label. So let's go ahead and build that. And what I want to do here is open up Chrome and the simulator side by side. So let's do this cupcake image. Going, added some data to Firebase. Boom, we've got a bunch of labels. So it found birthday cake, buttercream cake, all these different cupcake labels. So if you had a lot of images, you could do things like, count the frequency of different labels that you found, detect trends in the types of images that people were uploading. So if I do another image, let's try another one just for fun. Let's do this picture of a cat. There we go. We got some more labels. Cat, domestic long-hair cat. It's not sure if it's a long-hair, short-hair cat. Norwegian forest cat, vertebrae, whiskers. All of these it's finding in the image. So basically in just a couple lines of Swift code, we've created an app that can do all this like powerful machine learning analysis on an image, and then it's storing that data in a database somewhere in Firebase. One more thing I wanted to show was the landmark detection. So since I have some time left, we'll add landmark detection here to our request. And I've preloaded some images on the simulator that identify some pretty cool landmarks. So we'll change that to landmark detection. We're just going to return one result because we just really care about like the first thing it identifies as the landmark it found in the image. So I'm going to go down here to, after I go through the face annotations, scroll up so you guys can all see that. So here's where we're going to write our landmark annotation code. So we're going to say let landmark annotations. It's going to be of type JSON because we're using that cool Swifty JSON pod. And this is just going to be the landmark annotations object within our larger response object. So the next thing we want to do is we want to say if landmark annotations is not nil, so if it found a landmark, we're going to assign that landmark to a variable. So we're just going to say let landmark equal landmark annotations of 0. And to make sure I did that right, I'm just going to print the landmark to the console here. So let's run that. Simulator, and I preloaded this with some landmarks, one of which I think you might recognize, the cherry and spoon. That is a Minneapolis favorite sculpture. I'm a fan of it. There we go. So let's see what it found. So it did indeed find Minneapolis Sculpture Garden, and then it returned a bounding box of where in the image it found the landmark, along with the latitude and longitude and the confidence score. So the last thing I want to do here is, I won't display those in the UI, but let's just send the landmark data to Firebase, just so we can see how easy it is to write some more metadata about our pictures to Firebase. And there's also some cool landmark images I found that it was able to identify. So we'll say self.ref.child by appending path, and we'll just store all the landmarks under a /landmarks node. And then we're going to say child by appending path. Oops, we actually need to get the landmark description. So we'll say let landmark name equal landmark description. I think it was called description. Yes, so we're just getting the description. And then we're getting the string value, which is just a convenience method that's provided by Swift.json. And so then we're going to say child by appending path landmark name, which is a string, and then we're going to set the value to true. So once again, we'll build. And I also wanted to find some images of landmarks that I didn't know that it was able to identify. So, well, this one I do. This is Stonehenge, but I'll pull up Firebase so we can see the landmarks. I was able to find Stonehenge. I found some other more obscure ones that I had never heard of. Let's find this one. Grand Castle. Never heard of that one, but the Vision API was smarter than me. Here's another one. Mount Saint Michel, the castle that it was able to recognize. And we'll do one more. Just like that. Just go here. We'll do this one. Another one, Castle Burkhardt, which I probably mispronounced. But that hopefully gives you an idea of what you can do with the Vision API and all the different metadata you can get. There's a bunch of different possible use cases for this. So one would be, I didn't demo the safe search that it's able to do, so it's able to identify inappropriate content. That's a pretty big use case. Another thing is just getting a lot of metadata on a large quantity of images. And then the OCR, the text recognition, is also pretty powerful. So if you wanted to do things like upload receipts to categorize your expenses, you could build an app that is where people are able to take a picture of their receipt and it just automatically knows what was in there. It's able to auto expense report all of your things for you. So those are just a couple examples. I think I just have a few more slides. I'm going to go back here. A couple of resources. So as I mentioned, it's currently in alpha right now. So you do need to sign up to use it, but it's super easy to sign up. You can go to cloud.google.com/vision. We'd love for you to try it out, and if you have any feedback, definitely open to hearing it. Come talk to me after. If you have any specific feedback, I'd be happy to pass it along to folks on the team. There's a blog post that announces the alpha of the Vision API. It has some more information. I made a bit.ly link of it, so bit.ly-vision-api-blog. If you want to get started with TensorFlow, just go to tensorflow.org. There's a bunch of great tutorials on there. And then Jeff Dean, who's an engineer at Google, has a really good presentation on neural networks. If you want to understand more of the machine learning side of what's going on behind the scenes in the Vision API, I made a bit.ly link for some slides, some really good slides that he has on that. So bit.ly/google-brain-ml machine learning. I do have one more thing. So what is a presentation without one more thing? GCP Next 2016 is a really cool conference that's happening March 24th and 25th in San Francisco. You can sign up today, March 23rd and 24th, sorry. So it's a user conference for developers that are using Google Cloud products. There'll be a lot of really interesting presentations, some code labs, great learning opportunity if you want to get more familiar with all the different cloud products, meet a bunch of people on the team, some engineers, some other developer advocates, and meet other people that are doing cool things with cloud products. So I definitely recommend checking it out. If you have any questions about how to sign up, you can let me know. I have one more slide about that. Yes, so you should definitely go sign up. And that's all I've got. So ended a bit early, but it's the end of the day, so you can do that.
Actually, a couple.
Yes.
The latitude and longitude that's returned with the locations, is that the location of the landmark or the location where the photo was likely taken from?
I believe it's the location of the landmark, but I would have to confirm that with you. I can get back to you on that.
And
what?
How soon will we see this in Picasa?
In Picasa? That is a good question. I do not know the answer. Unfortunately. But yeah, you can definitely sign up to try out the API. So if you want to build your own application on top of it, recommend doing that. Yes.
A couple of quick questions regarding privacy. You mentioned that you could upload your receipts. Are these images in any way saved or stored, or are they destroyed after the algorithm is run?
I don't believe they're stored, but I also need to confirm that with you. But I can definitely find out for you after.
And then one follow-up to that, with the landmarks, I guess, how are those determined as landmarks? And with, for example, somebody's house ever show up as a landmark on a map, or are they specific to public places?
Yeah, they're all public landmarks.
Okay.
So I don't believe that like any obscure thing in your house would show up. So all things that are like pretty well known. Yes, in the back there.
Is there a minimum resolution that you need to provide? I'm just thinking about remote devices that are basically sending these images up. I want to do analysis on
I
them.
don't know about a minimum resolution. There is a maximum file size right now, which I believe is 2 megabytes, but I need to confirm that for you. I will get back to you though on the minimum resolution. That's a good question. Yes.
Yeah, so with the landmark recognition, how well does it work with geographic features that, maybe more or less just looks like a hill, but it happens to be a famous hill?
I guess that kind of depends on the picture. Like I was playing with it and found that like there was certain images, like Harry Potter World, for example, there were certain images of that it didn't pick up on Harry Potter World, but it said like Islands of Adventure.
Okay.
So I guess it just depends on the specific image. You might be surprised.
Yeah, what I had in mind are these hills in Scotland that have like sort of a white monolith on top, which is, I guess, the only distinguishing feature, unless you could also like pick out like the city in the background or something like that.
Do they have a name that like people would recognize?
Well, like there's St. Arthur's seat
Okay.
in
I mean,
Edinburgh.
it's definitely worth a try.
Yeah.
Depending on the picture, it might be able to pick it up.
Is there a limitation on the number of pictures you can send?
Oh, in terms of like pricing?
Yeah.
So right now in the alpha, the pricing hasn't been announced yet, but there will be some sort of pricing
So
limitation.
subscription model going forward?
Yeah,
Got it.
on number of requests, likely.
Sure. Thanks.
Yes.
So earlier there was a presentation on mobile vision API.
Okay.
Sounds like it was pretty much limited to face and barcode detection, but the face detection seems pretty much the similar or maybe a little bit more limited version.
Mhm.
Is this, and it sounded like that hadn't been updated in a while, is this sort of a successor to that, or is there any sort of, I know this is just really an alpha,
Yeah, this one is very new, so it's
Like-
definitely like the latest.
going back to the mobile vision API.
Do you know what was the API that the presentation was on?
It was, as far as I was aware, it was called Google Mobile Vision API.
I think it's
It's part of-
Android.
And
Yeah,
It's part of
okay.
Google Play Services.
Yeah.
Okay, I'm not super familiar with that one, but this one is definitely like very new, so it's got the latest facial recognition. So it doesn't do facial recognition, so it can't tell you like who a specific person is. In your
Neither did
images.
that one.
Yeah, that's just real limited detection,
Okay.
but it had the, like, can detect people's faces, eyes, mouth,
Okay.
stuff. So,
Yeah, but this one is very new, so it's got like all the latest capabilities. Yes.
Can you train this with your own specific data?
So this one you can't train, because it kind of takes care of it for you. So the idea is to make it easy for, developers that don't want to like build and train their own models. But with TensorFlow you can do that. So if you want to create your own models, just train them to do it all that. Yes.
The confidence numbers that were returned, they didn't seem to add up to 100, so I'm wondering what those confidences are.
That's just like the